We've got some fresh images of 3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system now.
Imagine the night sky above you, still, quiet, but not empty. Sometimes, something unusual passes through. Not a star, not a planet. A visitor, far away, across the dark. It glides silently. No engines, no signals, just motion. Astronomers gave it a name, 3I Atlas. But the name isn't the mystery. The mystery is what it carries. It is only the third object ever seen from beyond our solar system, and it has already unsettled some of the brightest minds at Harvard. So, settle in. Let's follow this quiet traveler together. And, if you enjoy this calm journey, don't forget to subscribe for more. Close your eyes. Picture a soft, endless sky. Dark, silent, infinite. Most of the time, when astronomers look upward, they see familiar things. Stars, planets, comets are born right here in our solar system. Objects that feel like neighbours. Even if they are far, far away, but sometimes something different appears. Something foreign. Something that does not belong to the family of the Sunday. In 2017, we met the first of these outsiders. Oumuamua, long, strange, moving in ways no one expected. Then came Borisov in 2019, more like a comet, bright tail, gas, dust, activity, familiar in shape, but still from another star. And then, in 2024, came the third, the one we now call 3I, Atlas. The 3I is simple. It means it is the third interstellar object ever discovered. The Atlas comes from the telescope that first spotted it, a survey system scanning the skies, always searching for motion. But the name is more than a label. It is a marker of history, a line drawn in the quiet book of astronomy, because every interstellar object we find is more than just a rock. It is a messenger, a traveller, carrying the fingerprints of another star system. Think of it like this. Most comets in our skies are born alongside our Sunday. They carry memories of our solar system's childhood. But 3I, Atlas, it was shaped somewhere else, in another nursery of stars, under conditions we may never see with our own eyes. The dust inside it, the ice is buried deep within, the chemical traces it leaves behind. All of these are pages in a story older than us, older than Earth itself. This is why Harvard scientists pay close attention, not because the object is dangerous, but because it is rare, incredibly rare. We see one, we study it, and then it is gone, racing away, forever. The fear comes not from the object itself, but from what we might miss. Each visitor is a chance to learn about worlds we will never touch. If we do not look closely, if we do not prepare, we may lose secrets that will never come again. So, the name 3I, Atlas, is not just a catalogue number. It is a reminder, a whisper from the stars, telling us, you are not alone in this galaxy. You are part of a greater story, a slow, steady story, written in ice, written in dust, carried by travellers who appear only once, and vanish into the dark. The night sky is usually predictable. Stars rise, planets drift, comets circle back after long journeys. But sometimes, something unexpected cuts across that steady rhythm. An outsider, a visitor from another star. The first came in 2017, Oumuamua. Its name means a messenger from afar arriving first. It lived up to the name. No tail, no coma, just a strange, elongated body, moving too fast, accelerating in ways no comet should. Scientists were baffled. Some whispered it could be artificial. Others thought it might be a fragment of a shattered world. Whatever it was, Oumuamua was different. And before we could understand it, it was gone. That was the first warning. The universe was telling us, you are not prepared. You need to look closer. You need to be ready. 2 years later, another visitor appeared. Borisov. This time, it looked like a comet. A bright nucleus. A gas tail stretching into space. Familiar, but not from here. Its chemistry carried the fingerprints of another star. Another solar system. A cosmic recipe book written in alien handwriting. This was the second warning. The message was clear. The galaxy is full of travelers. They pass by more often than we think, but we only see a few. Most slip past, unseen. And now, the third, 3I, Atlas. Bigger, brighter, stranger still. Unlike Oumuamua, it is not silent. Unlike Borisov, it is not ordinary. It has activity unlike anything we have measured before. Jets of gas, clouds of dust, behavior that defies easy categories. This is the third warning, the most serious of all, because it tells us the truth. The galaxy is alive with debris. Worlds are breaking. Stars are ejecting fragments. And some of those fragments pass right through our neighborhood. 3 visitors, 3 chances to learn, 3 reminders that our solar system is not sealed off. It is open, connected, part of a wider galactic web. The warnings are gentle, but firm. Do not assume Earth is the center. Do not assume the sky is empty. Do not assume you have all the time in the world. Each visitor stays only briefly. A flash of insight. A glimpse of something otherworldly. And then, silence. The fear Harvard scientists feel is not of doom. It is a loss. Loss of knowledge. Loss of opportunity. Loss of understanding that may never return. 3 visitors. 3 warnings. And, perhaps, a 4th is already on its way. Atlas is not just another comet. Not just another streak of light in the sky. It carries a weight, a presence, a scale that dwarfs the visitors we saw before. Oumuamua was small, no bigger than a football field. Borisov was larger, roughly the size of a city block. But Atlas? It stretches across miles. A true giant, carving its way through the dark. And with that size comes power, an activity that cannot be ignored. When sunlight touched it, Atlas woke up violently. Jets of gas burst from its surface. Dust clouds expanded outward. It wasn't quiet. It wasn't subtle. It was a spectacle. This is what makes it different. It is loud in its arrival. It announces itself with every flash of vapor, every plume of frozen gas released into the void. Scientists looked closer. The brightness levels shocked them. No fading whisper like Oumuamua. No modest glow like Borisov. Instead, flaring activity. Light so intense, it demanded attention from telescopes across the world. The sheer scale of it changes everything. A giant comet means a violent past. Something powerful must have thrown it out of its home system. Not a gentle push, not a small nudge, but a cataclysm. Maybe a collapsing star. Maybe a gravitational war with a massive planet. Whatever it was, it hurled this enormous body across the galaxy. Its activity also changes what we can learn. The gases it releases are samples. Each molecule carries a signature, a fingerprint of the place where Atlas was born. The chemistry is pristine, uncontaminated by billions of years of starlight, locked away in ice until now. Think of it as a time capsule, a messenger frozen in deep space, only now opening its pages to us. But the challenge is speed. It is moving fast, racing through the solar system. Each day, it slips farther from reach, and with each passing moment, another secret is lost to the dark. This is why Harvard scientists are unsettled. Not because Atlas will harm us, but because it may pass too quickly, too brief, too mysteriously. We see its size, we see its fury, we see its trail of light, but we may never understand the full story. That is what makes Atlas different. Not just its body of ice and rock, not just its violent activity, but the urgency it creates, the knowledge that slips through our fingers, like sand. In the stillness of night, Atlas reminds us, the universe does not wait. It moves on, and so must we. Atlas is not small. It is not subtle. It is a giant. But numbers don't always mean much. Miles, kilometers, they sound abstract in the dark of space. So let's bring it closer. Imagine the tallest mountain on Earth, Mount Everest. Now imagine a comet that stretches wider than that mountain is tall. That's Atlas. Picture a city skyline, rows of towers, skyscrapers reaching into the clouds. Now place them side by side, one after another, for miles. That's Atlas. Think of a football field. Multiply it by hundreds of times, end to end. That's still smaller than Atlas. This is a body of ice and rock large enough to swallow cities, large enough to reshape a landscape if it ever collided with a world. Of course, it won't collide with us, but scale matters, because scale tells the story of power. The larger the comet, the more ice it holds, the more dust, the more frozen chemicals locked away since the dawn of another star system. When the sun touches it, the release is enormous. Jets of gas that stretch for thousands of miles, dust tails larger than planets. A glowing veil is visible across the sky. This is not a flicker, it is a beacon. Astronomers compare it to other visitors. Oumuamua, the strange, silent traveller. Borisov, the familiar comet. Both were small by comparison. Both are easy to miss. But Atlas? It demands attention. It fills telescopes with detail. It floods detectors with data. Even the coma, the glowing atmosphere around the nucleus, grew larger than Jupiter. Yes, Jupiter, the biggest planet in our solar system. Atlas's cloud of dust and gas stretched wider than that. It's like a single snowball releasing enough powder to cover entire continents. That is the scale we're dealing with. And yet, this giant moves quickly, racing across the solar system in silence, a mountain of ice sliding through the void. Its size makes it unforgettable, but its speed makes it fleeting. For us, it is both a gift and a loss. A cosmic marvel revealed, and then gone, no chance to hold it, no chance to bring it closer. Only a brief moment to look up and whisper, "There it goes." That is the power of scale. It humbles us. It reminds us of the vastness of the universe, of the things that pass through, larger than mountains, brighter than cities, older than our species. Atlas is not just a comet. It is a giant, and in its presence, even Earth feels small. On the surface, Atlas is beautiful, a glowing giant, a cosmic show in the night sky. But behind the calm, scientists worry, especially at Harvard. Not because it's going to crash into us. That's not the fear. The orbit is clear. The path is safe. The concern is deeper. It's about what Atlas represents and what it reminds us of. Harvard astronomers study interstellar visitors closely. Oumuamua, Borisov, and now Atlas. Each one revealed a secret. Each one changed the rules. Atlas is the largest so far, and the most active. That raises serious questions. First, how many of these giants are out there? If 3 have already passed in just a few years, how many more pass unnoticed? How many escape our telescopes? That uncertainty worries scientists. Second, the ejection story. Objects like Atlas don't just wander off gently. They're thrown, launched by violence, by planetary chaos, by star systems tearing themselves apart. Atlas is evidence of a catastrophe in another solar neighborhood. That shakes researchers. Third, what it carries. This is material older than Earth's mountains, older than our species, locked away since the beginning of another star system. When the sun's heat wakes it up, we see inside. Chemistry, radiation scars, clues to alien histories. For Harvard, this is priceless, but also urgent, because the comet won't stay. The information will vanish with it. Fourth, Preparedness. If a body this large ever came too close, we are not ready. Our defense systems are built for smaller threats. Kilometer-scale asteroids. Not interstellar giants moving at tens of miles per second. We couldn't stop it. We could barely even track it. This truth unsettles researchers. Harvard voices it quietly. Measured. Scientific. But underneath, there's a pulse of fear. The fear is not of Atlas itself, but of the pattern it reveals. Visitors from the dark, travelers from other stars. Some small, some vast, all unpredictable. And so, Harvard pays attention. Every spectrum recorded, every image analyzed, every orbit is calculated again and again. Because Atlas is more than a comet, it is a messenger, a warning wrapped in ice and dust, proof that the universe still surprises us, still humbles us, still reminds us that our place is small, fragile, and temporary. Behind the calm tone of academic papers, behind the tidy graphs and quiet press releases, there's a realization. Atlas is beautiful, but it is also terrifying, not because of what it will do, but because of what it means. And that's why Harvard is paying attention. When people hear about a comet, fear often jumps to one place. Impact. Collision. The end of the world. But with Atlas, that's not the worry. Its orbit is safe. It will not strike Earth. It will not end civilizations. So why do scientists feel uneasy? Why does Harvard keep such a close watch? The fear comes from something quieter, something less dramatic, something harder to explain. It's the fear of the unknown. Atlas is a stranger. It comes from another star system. Its chemistry is not ours. Its past is hidden in light years of travel, and no one knows exactly what it carries. Think about that. A piece of another world drifting into ours. We can observe it. We can measure it, but we cannot predict it perfectly. Every time an interstellar visitor arrives, our models shift. Oumuamua broke expectations. Borisov confirmed theories and shattered others. Now Atlas has rewritten the rules again. That's unsettling, because science loves patterns. Science thrives on certainty. But these visitors, they refuse to play by the old rules. The fear isn't physical danger. It's an intellectual danger, a reminder that we don't know as much as we thought. What if there are thousands more objects like Atlas? What if some are darker, quieter, almost invisible? What if some pass close enough to stir up Earth's environment? We don't have those answers. This is what Harvard scientists wrestle with. Not panic, not doom, but the discomfort of uncertainty. And in a way, that's a deeper fear, because you can prepare for a rock on a collision course. You can build defenses, launch rockets, and design plans. But how do you prepare for the unknown? Imagine standing at the edge of a dark forest. You hear sounds inside. You know creatures live there, but you don't know their shapes, their numbers, their habits. That feeling of not knowing, that's the essence of the fear around Atlas. It's not about being destroyed. It's about being surprised. Atlas is a reminder. The cosmos is full of mysteries. And, even in the age of supercomputers and space telescopes, we are still explorers with lanterns, peering into the dark. The nature of fear here is subtle. Not Hollywood explosions, not disaster headlines, but quiet unease. The shiver of realizing the universe is bigger, stranger, and more unpredictable than we imagined. That is why scientists watch Atlas with awe and also with caution, because it's not the comet itself that frightens us. It's everything we still don't know. We live under the stars. We think we see them. We think we know the sky. But the truth is humbling. We miss almost everything. Even with giant telescopes, even with space-based observatories, even with all our technology, the cosmos keeps its secrets. Why? Because space is vast, unimaginably vast. Our field of vision is tiny. Our instruments, though powerful, are limited. Picture a flashlight in a stadium. That's our vision of the universe. A narrow beam surrounded by darkness. Most things slip past unseen. Comets like Atlas prove it. They appear suddenly, bright, mysterious, and then we realize they were there all along. But we didn't notice. We miss faint objects. We miss small objects. We miss fast objects moving across the background of stars. Even Earth-crossing asteroids have surprised us. Some have flown between us and the moon, detected only after they passed. Sometimes, not at all. It's not because scientists aren't trying. They are. Sky surveys sweep constantly. Supercomputers crunch data. But the universe is just too big, too busy, too full. Imagine watching waves on a beach. You count a few, but you know you're missing hundreds more. That's astronomy. That's our search for cosmic visitors. Light is another limit. Objects far away are dim. They reflect almost nothing. Dust hides them. Sunlight blinds us. Our view is always filtered. Then there's time. The sky changes. But we can't watch all of it all at once. We take snapshots. One region, one night, move on. And in that gap, something can pass unnoticed. Atlas reminds us of these blind spots. It tells us, you're not seeing the full picture. For every comet we find, there may be dozens we miss. For every interstellar traveler we track, others slip silently by. That's unsettling, because what we don't see could matter most. The faint, the hidden, the rare. Harvard scientists know this. That's why they push for better surveys. More telescopes, faster computers, global coordination. Because one observatory can't watch the whole sky, but many together, that's our best chance. Still, the truth remains. We are limited. Our eyes on the universe are small. Our reach is short. Our understanding is incomplete. And that's the haunting part. We don't just fear what we see, we fear what we can't. The limits of human observation aren't just technical, they're existential. They remind us we're still learning, still searching, still missing most of the story. And somewhere out there, in the unseen dark, other visitors may already be passing by. For every object we find, how many pass unseen? That's the question. It lingers in the quiet. It haunts astronomers, because space is not empty. It is busy. It is full of travelers, rocks, comets, fragments, interstellar wanderers. And yet, our count is so small. 3 confirmed visitors: Oumuamua, Borisov, Atlas. But the math whispers a different story. There should be more, thousands more, passing through every year, sliding silently across our skies, never noticed. They move faintly, they move quickly, they move in directions we aren't looking, and so they slip by. Imagine shadows crossing a forest at night. Your flashlight catches one branch, but 1,000 others move unseen. That's the sky above us, a canopy of shifting shadows. Even Earth-crossing asteroids remind us, some of the sizes of buses, detected only after they've gone. Some slip by without detection at all. If nearby objects escape our notice, what about those from the stars? Those carrying stories from other worlds? How many have visited already and left no trace? Think of Oumuamua. We almost missed it. It was faint. It moved strangely. By the time we noticed, it was leaving, already fading into the distance. Think of Borisov, a comet from another system. It blazed across the sky, but only briefly. And now, it too is gone. Atlas is different, brighter, bigger, but even if it was hiding in the dark, until the right eyes found it, it makes you wonder, what's out there now, passing between the stars, sliding across our solar system, drifting in the blind spots of our telescopes. Not dangerous, not terrifying, just unknown, unnoticed, untold. Astronomers call them shadows. Shadows we can't see, but we know they're there. Their absence is a presence. an echo. That's why Harvard scientists stay cautious. Because every discovery reminds us we're only scratching the surface. We're only catching glimpses. The unseen shapes our story. The missed objects shape our fear. It's not about collisions. It's about mystery. It's about how much escapes our eyes. So, the next time you look up at the quiet night sky, know this: it's full of motion, full of travelers, full of shadows you'll never see. And somewhere in those shadows, these are the ones that got away. The year was 2017. Astronomers spotted something strange, something unlike anything seen before. It wasn't from here. It wasn't local. It was interstellar. They named it Oumuamua, a Hawaiian word. It means a messenger from afar, arriving first, and that name fits perfectly. At first glance, it looked like an asteroid, a rocky fragment drifting through space. But then, it didn't act like one. Its shape was odd, long, slender, like a cigar, or maybe a flat pancake. Even today, no one really knows. It reflected light in strange ways. It tumbled as it moved. Its brightness flickered, almost like a signal. But here's where it got truly puzzling. Oumuamua accelerated, just slightly, but enough for scientists to notice. Asteroids don't do that. They move only under gravity, but this one seemed to push itself away. No tail, no gas, no visible outgassing like a comet. And yet, it moved. Was it shedding material too faint to see? Was it a new kind of object? Or something else entirely? For months, debates raged. Some scientists said a natural fragment. Others argued maybe a hydrogen iceberg, or a chunk of nitrogen ice. Exotic, but possible. And then there was the bold idea, a suggestion that grabbed headlines. Could Oumuamua be artificial? A probe? A fragment of alien technology? Harvard's Avi Loeb thought so. He argued its acceleration might come from sunlight pushing on a thin, sail-like structure, like a piece of alien space junk drifting across the galaxy. Or maybe something was sent intentionally. Most scientists disagreed. They leaned toward natural explanations. But the truth is, we still don't know. By the time the debate heated up, Oumuamua was already gone, speeding out of the solar system. Too fast to catch, too faint to study further, it left behind questions, a trail of mystery, and a reminder of how little we understand. Think of it like a shadow at the edge of vision. You see it, you know it's there, but before you can look closely, it's gone. That was Oumuamua, the first messenger, a riddle written in starlight. Maybe it was just a rock, maybe it was something more, but either way, it opened our eyes. It told us, we are not isolated. The galaxy shares its secrets. Sometimes they drift right through our backyard, and we almost missed it. Oumuamua came. It puzzled us. It left, and it whispered a truth we cannot ignore. The universe is stranger than we think. 2 years after Oumuamua, another interstellar traveler appeared. This time, things felt different. Its name was 2I, Borisov, discovered in 2019, spotted by an amateur astronomer with sharp eyes and sharper instincts. At first glance, it looked familiar. A comet, and not just any comet. The kind you'd see in a textbook. It had the classic features: a bright coma, a long sweeping tail, outgassing as sunlight warmed its icy core. Scientists breathed a sigh of relief. Finally, something that behaved as expected. Not a mystery cigar, not a riddle, but a comet, plain and simple. Telescopes worldwide turned toward it. Data poured in, and what they found was fascinating. Borisov wasn't ordinary. It was supercharged. Its activity was intense, even for a comet. It spewed carbon monoxide at levels far higher than most solar system comets. It shed material at a staggering rate. But still, it made sense. Its chemistry matched what theories predicted. Its behavior lined up with models. A comet born around another star, acting exactly like one from our own backyard. This was the proof astronomers needed. Oumuamua had left too many questions. But Borisov reassured them. It showed interstellar objects could be understood, studied, predicted. Think of it as a cosmic ambassador, a visitor who behaved politely at the dinner table. It introduced itself in a language scientists already knew, the language of ice and dust, the language of comets. Unlike Oumuamua, Borisov didn't just puzzle us, it educated us. It gave researchers hard evidence, solid data, spectra that told of alien ices, chemistry from another solar nursery. Every molecule it shed was a clue, a chemical fingerprint of its birthplace. It was like having a sample return mission from a star we'll never visit. And the timing? Perfect. Telescopes had improved. Survey networks were better connected. We caught Borisov early enough to study it properly. The results were remarkable. It confirmed what many had hoped. Interstellar objects aren't rare. They pass through all the time. We just needed sharper eyes to see them. But Borisov also carried a subtle warning. If this were the ordinary kind, then Oumuamua was even more extraordinary. The contrast between the two was striking. Oumuamua, the enigma, silent, strange, unexplained. Borisov, the comet we could understand, loud, bright, familiar. Together, they painted a bigger picture. The galaxy sends us many kinds of messengers. Some whisper, some shout. Borisov was the shout. The clear voice saying, yes, comets travel between stars. It was the interstellar visitor that made sense, the one that fit the textbooks. And yet, it only deepened the mystery of the one that didn't. Then came the third visitor, 3I Atlas, bigger, brighter, and far less predictable. If Oumuamua was strange, and Borisov was familiar, Atlas was something else entirely. At first, it looked like a comet. Icy body, long tail, gas and dust streaming out as it neared the Sunday. But then, the numbers didn't add up. Its activity wasn't just normal comet behavior, it was extreme, explosive, outbursts of gas and light, unlike anything we'd seen before. And its size? Monstrous. Where Oumuamua stretched the length of a football field, and Borisov matched a city block, Atlas dwarfed them both, miles across. A cosmic giant. That scale alone broke expectations. How could something this massive travel between stars? How did it survive the ejection from its home system? What kind of event could fling a mountain of ice into interstellar space? Scientists scrambled for answers, but the data didn't fit neatly. Atlas didn't just challenge models, it broke them. The chemistry seemed alien. Its activity levels didn't match its distance from the Sunday. It shed material faster than physics predicted, like a rulebook, tossed aside. And then came the deeper worry. If Atlas is this active, this volatile, what else could be out there? What other giants pass through unseen? It wasn't just a curiosity, it was a wake-up call. Oumuamua whispered mystery. Borisov spoke clearly. Atlas shouted in chaos. Astronomers began calling it a rule breaker for a reason. Not because it broke one theory, but because it cracked many at once. Think of it like finding a creature that looks familiar, but behaves in ways that biology says it shouldn't. You recognize the body plan, but the behavior rewrites the textbook. That's what Atlas Island, a cosmic anomaly wearing the mask of a comet. And here's the kicker. Its story is still unfolding. Unlike Oumuamua, which slipped away quickly, and Borisov, which followed predictable lines, Atlas lingers in data archives. Its traces still being studied. Its secrets are still debated. Some see it as a natural giant, born in a violent nursery around another star. Others wonder if something even stranger is at play. But everyone agrees on one thing. Atlas defies easy explanation. It doesn't behave like a comet should. It doesn't fit neatly into categories. And that's what makes it terrifying. Not because it's coming for us, but because it proves how little we understand. In the story of interstellar visitors, Atlas is the wild card, the rule breaker, the one that tells us the galaxy is stranger than we think. Here's the thing about interstellar travelers. They don't just carry dust and ice. They carry history. Think about what happens when an object spends millions of years drifting between stars. It's bombarded by cosmic rays. It's pelted by micrometeorites. It's frozen to near absolute zero. That kind of environment doesn't destroy everything. It transforms it. Over time, the surface becomes scarred. Radiation darkens the ice. Dust builds a crust. This outer shell acts like armor, protecting the chemistry inside. And inside, that's where the treasure island. Because while the surface records the hardships of the journey, the interior preserves something far more valuable: pristine material, chemistry untouched since the object's birth. That means when we catch one of these wanderers, we're not just looking at a comet. We're looking at a time capsule, a sample from another star system, a chemical memory of how planets formed light years away. Scientists call this interstellar archaeology. Not digging into dirt, but digging into alien ice. Every trapped molecule tells a story. What the parent star was made of, what the temperatures were like, whether organic molecules had already begun to form. It's like holding a postcard from another world, except the ink is atoms and the message is billions of years old. That's why Atlas, with its size and activity, is so important. Its violent outbursts peel back the protective shell, exposing chemistry we've never seen before. Clues hidden deep inside are suddenly streaming into space, right where our telescopes can read them. Water, carbon compounds, exotic isotopes, all whispering secrets from a time when Earth itself was still young. And that's the paradox. The same forces that threaten to tear these visitors apart, these are the ones that reveal their most precious secrets. Without solar heat, we'd never see beneath the crust. But too much heat, and the whole object disintegrates before we can learn enough. It's a race against time, a fragile balance, and every observation counts, because once the visitor is gone, its story is gone forever. That's why scientists fear missing the next one. It's not just about discovery, it's about losing knowledge that may never return. Atlas isn't just a rule breaker, it's a reminder. Across the galaxy, countless travelers are carrying alien chemistry, waiting to be unlocked. And if we can catch them, we're not just learning about comets. We're learning about where we come from, and maybe where life itself begins. So, the next time you hear about an interstellar visitor, remember, it's not just ice and rock. It's a message in a bottle, a gift from another world. And hey, if you love unraveling these cosmic mysteries with me, don't forget to subscribe, because the universe isn't done surprising us yet. Every interstellar visitor is a story, not written in words, not carved in stone, but encoded in molecules. Think of Atlas as a book. The cover is scarred, darkened by radiation. But open the pages deep inside the ice, and you'll find an autobiography of atoms. Every molecule is a chapter. Every isotope is a sentence. Together, they whisper the history of another star system. When astronomers point their spectroscopes at Atlas, they're not just collecting light, they're reading. Water molecules glow first, hydrogen and oxygen, fused long ago in the hearts of stars. But look closer, and you see subtle variations. The ratio of heavy hydrogen, deuterium, to light hydrogen. This ratio is a signature. It tells scientists the exact conditions under which that water froze. Temperature, pressure, even the chemical environment of the stellar nursery where Atlas was born. It's like finding a diary entry from billions of years ago. Here's what it was like when I formed. Then comes carbon. carbon monoxide, carbon dioxide, organic compounds locked in the ice, simple chains, but also hints of complexity. These molecules matter because carbon is the backbone of life. The fact that Atlas carries them proves something profound. That alien chemistry, far from our sun, follows familiar rules. Carbon wants to bond. It wants to build. It wants to create the foundations of biology. Every atom of carbon in Atlas is ancient, forged in the furnace of a dead star, launched into space by a supernova, and now drifting in frozen form into our telescopes. If atoms had voices, they'd tell us of their long exile across interstellar space, and how they survived by hiding in the deep freeze. Even nitrogen has a tale to tell. Traces of ammonia hint at the chemical soup that once circled a distant Sunday. Mixed with carbon, nitrogen can build amino acids. And amino acids, as we know, are the first stepping stones toward life. Oxygen, too, has a role, not just in water, but bound with silicates and minerals, fragments of rocky dust embedded in the ice. Each grain is a shard of the planet-building process, proof that Atlas was born in a system that had both gas and rock, a place not so different from ours. And then there are the isotopes, the tiny variations of common elements. Like different accents in the same language, they don't change the words, but they reveal where the speaker grew up. Oxygen isotopes, carbon isotopes, hydrogen isotopes. Each one points to a different part of the galaxy. Together, they sketch a chemical fingerprint unique to Atlas, a signature that says, "This is where I came from. This is the neighborhood that made me." This is why scientists treat interstellar objects like sacred texts. They are samples, delivered free of charge, from places we may never visit. And it's why Atlas is feared and cherished all at once. Because when its molecules stream away in the solar wind, they carry stories we'll never hear again. If we don't catch them now, if we don't read fast enough, the autobiography burns up in sunlight and the knowledge is gone forever. Think about it. When Earth was still molten, Atlas's atoms were already writing their first chapters. When the first forests grew here, its molecules were still drifting between stars. Now, by cosmic chance, their story intersects with ours, and we get to read a few pages. Not the whole book, just fragments, enough to know we're not alone in chemical history. Atlas is a messenger, a frozen biography. Its molecules tell us where it came from, how it survived, and what its parent system was like. It's not fear of collision that drives Harvard scientists. It's the fear of silence, fear of missing the autobiography of atoms. Because once the pages sublimate into space, that story is gone forever. Water, so familiar here on Earth, so ordinary, we drink it. We bathe in it. We barely think about it. But when water comes from another star system, it stops being ordinary. It becomes a story. Inside Atlas, there is ice, frozen for billions of years, locked away in darkness so deep, radiation only touched the outer shell. That ice is more than frozen water. It is alien water. And hidden in that water are clues. Tiny, invisible, yet powerful. Isotopes. What are isotopes? Atoms with the same identity, but slightly different weight. Hydrogen, for example. The light kind we drink every day, and the heavy kind called deuterium. On Earth, the ratio of light hydrogen to heavy hydrogen is stable, predictable. But in Atlas, the ratio is different. Strange, alien. It's like tasting a familiar dish, but finding the spice all wrong. You know it's water, but it doesn't feel like home. This matters because isotopes are storytellers. They reveal the environment in which they froze. Cold regions of space trap more heavy hydrogen. Warmer regions trap less. The exact ratio is like a signature, a cosmic birth certificate. By measuring isotopes in Atlas, scientists can trace its origins, not just out there beyond the stars. But where exactly does it form? What kind of star cradled it? What kind of chemistry surrounded it? Alien water becomes a postcard, stamped, signed, sent across light years. But there's more. Sometimes these isotopes don't match anything we know. Not Earth, not comets, not meteorites. Something entirely different. That's when the stories get strange. What kind of environment could produce such ratios? A massive young star? A binary system tearing itself apart? Or a planet's icy moon shattered in infancy, casting fragments into the galactic highway? Every answer feels like speculation, yet every measurement is real. The water doesn't lie. And then, the haunting thought, what if alien water seeded our own world? Billions of years ago, comets and asteroids slammed into Earth, delivering oceans drop by drop. If even one of them carried isotopes like Atlas, then parts of our seas are alien. When we drink water, we may already be drinking the galaxy. That possibility makes Harvard scientists pause, because Atlas isn't just another comet. It's a reminder that our planet's story might be stitched together from interstellar threads. Alien water also carries organics, carbon chains wrapped in the ice, frozen chemistry waiting to thaw. Strange isotopes mean strange environments, and strange environments mean possibilities. Recipes for molecules Earth has never seen. Imagine a drop of alien water melting here. Its isotopes whisper a story Earth has no words for. Its molecules hint at chemistries that could build new patterns of life. Not life itself, but the ingredients, blueprints written under alien suns. The danger is that stories fade quickly. As Atlas nears the sun, its ice turns to vapor. The isotopes scatter into space. The secrets dissolve into the void. That's why scientists work in a frenzy, capturing spectra, measuring ratios, trying to save the story before the pages burn. Because alien water is not just science. It is memory. It is history. It is the autobiography of another system's ocean. Think about it. When you sip water tonight, you are sipping atoms billions of years old. But none of them traveled the way ATLS did. None of them crossed interstellar highways, preserving their strange isotopic scars. That's why this comet matters, not for its danger, not for its size, but for the alien water it carries. Water that doesn't quite belong here. Water that tells alien stories. And stories, once lost, they are gone forever. The universe doesn't wait. Not for us. Not for anyone. Atlas reminds us of that. It moves fast, blindingly fast, too fast for comfort. From Earth, it looks like a slow traveler, a dot creeping across the stars. But in reality, it is racing through space at tens of kilometers per second, faster than a bullet, faster than anything we've ever built. That speed gives us a problem of time. When comets orbit our sun, we have centuries. They come back again and again. We can study them slowly, patiently. But interstellar visitors? They are one-time guests. They arrive unannounced. They pass through once, and then they are gone, forever. No second chance. No repeat orbit. Only a single window. And it closes quickly. Think of it like this. Imagine a bird flying through your garden. It doesn't land. It doesn't stop. It just cuts across the sky in seconds. If you want to see it, you must look now, not later, not tomorrow. Now, that is Atlas, a cosmic bird, here and gone in the blink of an eye. Astronomers feel the pressure. Every night counts. Every hour matters. Every image is precious. Because the faster it moves, the harder it is to track. Its path bends under the sun's gravity. Its brightness changes as ice boils away. The clock ticks, and the comet slips farther into the dark. This is why Harvard is right and observatories around the world pay such close attention. They know the window is short. They know the opportunity will never return. It's a strange kind of fear, not fear of danger. Fear of missing something important. Fear of ignorance. Our technology helps. Automated telescopes sweep the sky. Computers compare new pictures with old ones. Algorithms flag moving dots in the sea of stars. But even with all that, we're racing against nature, against orbital mechanics, against time itself. Atlas reminds us of our limits. Our smallness. We are slow creatures. We take years to plan missions, decades to build a spacecraft. But interstellar objects? They don't wait for our schedules. They just pass by. The best we can do is watch. Watch fast. Watch carefully. Gather what fragments of knowledge we can before the visitor leaves. And there's another truth. Every observation is imperfect. The faster Atlas moves, the blurrier the details become. We want sharp answers. But speed smears the story. We end up with pieces, hints, mysteries. It's like trying to read a book while it's being tossed past you in the wind. You catch a sentence here, a word there, but never the full page. That's why speed creates awe and frustration and urgency. Scientists know this is history in motion. If we miss it forever. There is no replay button in astronomy, so they stay awake, night after night, tracking, measuring, recording every flicker, and still, it may not be enough. The comet's speed is merciless. Our time is short, our chance is fragile, but that's also what makes it beautiful. It is rare, it is fleeting. It reminds us to look now while we still can, because tomorrow, Atlas will be farther away, and soon after, it will be gone into the dark, carrying its secrets with it, leaving us with memories, data points, and questions. Questions that may take decades to answer, or never. That is the race, not against the comet, but against time itself, a race we can never win, only endure. And in that endurance, we learn, we grow, we remember. Atlas moves on. But for us, the clock keeps ticking. Our telescopes are powerful, but they are not perfect. They see much, but not everything, and that is the problem. The night sky feels endless. Billions of stars, countless galaxies, an infinite dome above us. But our vision? It is narrow. It is small. Astronomers look up, but they cannot look everywhere at once. They choose patches. They scan slices. They stitch them together like a quilt. But between the stitches, blind spots remain. The biggest blind spot of all? The Sunday. Objects that approach from the sun's direction are hidden, invisible in the glare. Our detectors are blinded. Our cameras are overwhelmed. We can't see past that brilliant fire. So, if an interstellar object comes sunward, we lose it completely. Imagine standing at the beach. The ocean stretches wide. Ships sail by on the horizon. You can spot them easily, but then you turn toward the setting Sunday. Its glare burns your eyes. Anything on that side vanishes in the light. Boats, birds, waves, all invisible in the brightness. That is astronomy. That is our blind spot. Many objects slip past this way. We never even know they were there. By the time the sun's glare releases them, they are already racing away. Too faint, too far, lost. Each lost object is a missed chance, a mystery erased, a story never told. Oumuamua almost escaped us this way. It was spotted late, already heading out, already fading. We had only weeks to study it, and then it was gone. How many others like it never even made it into the record? How many cosmic messengers passed unnoticed because they travelled on the wrong side of the sky? We'll never know. That uncertainty worries scientists, not because of danger, but because of ignorance. Every blind spot is a silence. Every silence is a gap in the story of our universe. And there are other blind spots too, crowded star fields, places where background light makes faint objects vanish, dust lanes in the Milky Way, clouds in Earth's own atmosphere. Even the limitations of telescope time, all these create shadows where visitors can hide. Think of it like watching traffic through a keyhole. You see the cars that pass directly in front, but most, they drive by unnoticed. Only the rare few line up with your narrow view. That is how interstellar traffic moves. Almost all unseen, almost all missed. The frustrating part? We know they are out there. Computer models prove it. Galactic highways carry debris everywhere. Our solar system lies at a crossroads. Visitors should be common, but we see only a fraction. The rest vanish into blind spots. This is why Atlas matters. It came from a direction we could see. It was bright enough, active enough, lucky enough, and we caught it. But Harvard scientists wonder, how many more Atlas-sized visitors have we missed? How many slipped past in the glare of the sun? How many secrets dissolved into darkness before we even knew they were here? It's a haunting thought. We are surrounded by cosmic messengers, but our eyes are half closed. Our instruments blink. Our field of vision is tiny. The universe keeps speaking, but we hear only whispers, fragments, echoes, and the rest, lost forever in the light. That is the problem of blind spots. The fear of what we don't see, not danger, but absence, not impact, but silence. The sun blinds us, the cosmos hides from us, and the truth slips away. The universe is vast, endless, overwhelming, and yet we see it through a keyhole. Our telescopes are strong. Our technology has advanced. But even the best eyes in space have limits. They cannot watch the entire sky at once. They can only look here or there, never everywhere. Think about how small our field of view really island. A telescope gazes at a patch of sky. It might look huge on the screen, but in reality, it's a speck, a grain of sand against the desert of the cosmos. Astronomers stitch these specks together, image after image, night after night, like a giant jigsaw puzzle with missing pieces. But the puzzle is never complete. There are always gaps, always holes. The sky keeps moving. Stars shift, planets wander, comets streak across, and our keyhole view tries to keep up, but it is slow, always behind, always chasing. Imagine watching a parade through a narrow crack in a wall. You see one marcher, then another, but never the whole parade, never the full picture. That is astronomy. That is our view of the universe. And in those missing spaces, things slip by. Silent visitors, cosmic travelers, interstellar objects racing past. Most are never seen, never recorded, never known. The sky is too big. Our tools are too small. Our time is too limited. We miss far more than we catch. Even great surveys, scanning widely, cannot escape this truth. Projects like Atlas, Pan-STARRS, Catalina, they sweep huge regions, but still only pieces, only fractions. Blind spots remain, and blind spots mean lost chances. Consider how many interstellar visitors must have passed already. Hundreds, thousands, each carrying secrets, each carrying stories of alien suns. We spotted only three in all of history, 3 through the keyhole. The rest vanished without a trace. Think about that scale. The difference between what is and what we see, like watching the ocean through a straw. You glimpse a ripple, a wave, but never the depth, never the horizon. This is why scientists worry. Not about collisions, not about impacts, but about ignorance. Every unseen object is lost knowledge. Every blind pass is a story erased from our cosmic library. And the clock keeps ticking. Objects move fast. They do not wait for us. If we don't spot them in time, they fade. They disappear into the dark, gone forever. Our field of view shapes what we know, shapes our science, shapes our imagination, but it is so narrow. so fragile, so small against infinity. We see only what passes through the crack. The rest remains hidden, and the hidden may be greater, stranger, more important than anything we've ever glimpsed. This is the keyhole view of the cosmos, a truth that humbles, a truth that haunts, and a truth that drives astronomers to keep watching, keep scanning, keep searching the dark, hoping that the next messenger passes where our eyes can see. Because if it doesn't, we will never know it was there. The greatest fear is not destruction. It is an absence of knowing, absence of answers. When an interstellar visitor passes by, it brings with it a story, a history written in ice, rock and dust, a chemical diary of a star system we may never see. It carries the fingerprints of alien suns, the whispers of long-dead worlds, a frozen memory of time before we were here. And yet, most of them slip past unseen, unrecorded, unremembered, like a page torn from a book we were never allowed to read. That is what scientists fear most, the silence of ignorance, the loss of knowledge that can never be regained. Oumuamua gave us a mystery, a riddle we could barely begin to solve before it was gone. Borisov offered clarity, proof that alien comets exist, behaving as the textbooks predicted. And now, Atlas, a cosmic giant, a chance to learn more than ever before, but only if we catch it, only if we see it clearly, only if we act before time runs out. The fear is not of impact, the fear is of blindness. The idea that we are surrounded by wonders, and yet our eyes are too weak to see them. Imagine a museum filled with treasures, ancient relics, priceless artifacts, and imagine being led through in the dark, a flickering flashlight showing you only a handful. The rest vanish into the shadows. That is astronomy with interstellar visitors. We know the treasures are there. We know they hold secrets. But we are walking in near darkness. Each object is unique, unrepeatable. Once it leaves, there is no second chance. We cannot call it back. We cannot recreate its path. Its chemistry, its story, its truths, they are gone forever. That permanence is terrifying. It makes every lost opportunity feel heavier. Every missed detection feels like a wound to human curiosity. Because this is not just about rocks and ice. It is about perspective. It is about our place in the galaxy. These messengers carry proof of connection, that we are not isolated, that star systems exchange material across impossible distances, that alien chemistry flows into our solar system, that life's building blocks may not belong to one world alone. Miss one and you lose that lesson. Lose 10 and you erase whole chapters of galactic history. Lose 100 and you may never understand the larger story at all. This is why Harvard scientists and others like them are uneasy, not because Atlas threatens Earth, but because it threatens to escape before we can understand it. Because the cosmos does not wait for us to be ready. It moves on endlessly, cold, fast, uncaring. The fear of missing knowledge is quiet. It does not scream. It lingers. It reminds us that ignorance is the true danger, the kind of danger you only realize when it's too late. So the race is not against impact, it is against silence, against the void, against the eternal regret of not knowing what passed right before our eyes. That is the weight of every interstellar visitor, not destruction, but the once-in-a-lifetime chance to learn and the unbearable thought of losing it. The cosmos doesn't follow our rules. We build models. We write equations. We draw neat diagrams in textbooks. But every so often, the universe sends something across our path to remind us we might know far less than we think. That's where the real fear lives. Not in impacts, not in fiery collisions, but in surprises. In the possibility that 3I, Atlas, is something that doesn't fit any category. Think of Oumuamua, the first interstellar object we ever spotted. It didn't behave like a comet. It didn't behave like an asteroid. It was long, flat, and moved strangely. No tail, no glow, and yet a mysterious acceleration as if pushed by some invisible force. It broke every rule. It left us with more questions than answers. Then came Borisov. The perfect comet behaved exactly as expected. Outgassing, tail, chemistry, we understood. It reassured scientists that not every visitor would throw our theories into chaos. And now, Atlas. Bigger, brighter, wilder. Its behavior stretches the limits of what we've seen before. Not just a comet, not just a rock, a rule breaker, a cosmic curveball. So, what's the fear? That Atlas might reveal something we've never imagined. It might show alien chemistry that rewrites our understanding of planetary formation. That it might hint at processes we don't have names for. It might carry compounds that don't exist anywhere in our solar system. Imagine scientists staring at their data, spectra showing lines they can't match to known molecules, ratios that don't add up, patterns that shouldn't be possible. That is what keeps them awake at night. Because if Atlas doesn't fit into our neat categories, we'll have to redraw the map, rewrite the theories, question what we thought we knew about the galaxy itself. And here's the twist. We may not even have time to fully study it. The window is short. The observations are fleeting. If the data slips away before we understand, the surprise will remain locked in mystery, a truth glimpsed but never grasped. The fear of cosmic surprises isn't just about science. It's about humility. It's about realizing that we might be standing on the edge of discoveries far stranger than we expect. That we live in a universe full of materials, forces, and histories we haven't even begun to imagine. Think of explorers centuries ago, sailing into the unknown. They expected to find new coastlines, but sometimes they found entire continents. What if Atlas is like that? Not just another comet, but evidence of something vast and uncharted. What if its chemistry suggests life-building compounds are far more common than we thought? What if its structure hints at violent cosmic events we never predicted? What if, most unsettling of all, it shows signs of processes we can't yet explain? That possibility is thrilling, but it is also terrifying, because humans fear the unknown more than anything. And Atlas, with its alien biography written in dust and ice, is the purest unknown we've ever had the chance to study. So Harvard scientists don't fear its impact. They fear its surprises. They fear looking at the data and realizing our universe is stranger, wilder, and far less predictable than we dared to believe. And the scariest thought of all? That we might miss the chance to understand it. That the greatest surprise of all will slip past us, and we'll never know what it meant. Harvard scientists aren't afraid of comets. They're afraid of being wrong, afraid of watching decades of carefully built theories collapse overnight. That fear isn't weakness, it's respect for the unknown. Science is a discipline of humility. Every breakthrough carries a cost. It means throwing away old ideas and rewriting the very books students study from. And Harvard has seen this cycle before. Think back to the early days of astronomy. Theories of perfect circular orbits gave way to ellipses. The ether, once believed to fill space, turned out not to exist at all. Harvard professors taught those ideas with confidence until new evidence forced them to tear up the pages. It was uncomfortable. It was messy. But it was progress. That's why 3I, Atlas, creates unease. It looks like a comet. It acts like a comet sometimes, but then it defies the script. It bursts brighter than expected. Its chemistry hints at odd origins. Its sheer size makes it unlike the others we've seen. And suddenly, old categories don't fit anymore. Harvard, with its long tradition of cautious science, knows what that means. They've been through it. They've seen the fallout of rushing to explain mysteries too soon. Better to pause. Better to study. Better to fear rewriting the textbooks until the evidence demands it. Consider Oumuamua again. Some researchers leapt to bold claims. An alien probe, a light sail, a technology we couldn't recognize. Others, including Harvard's Avi Loeb, stood at the center of controversy by suggesting such ideas publicly. It shook the scientific world. It divided opinions. But it reminded everyone that the stakes are high when new data arrives. Textbooks are more than paper. They're consensus. They're the scaffolding of education, policy, and even funding. Changing them means admitting that thousands of lectures, papers, and models left out something essential. No scientist takes that lightly, especially at Harvard, where reputations are built on careful precision. So what do they fear with Atlas? Not a disaster, not destruction, but disruption. That this giant visitor will reveal chemistry that doesn't match known formation theories. That its journey through interstellar space carved signatures we've never seen before. That our neat divisions, asteroid, comet, icy body, are too simple for a galaxy filled with complexity. This fear isn't paralyzing, it's motivating. It drives Harvard researchers to gather every photon of light, every spectroscopic clue before the comet fades. Because if Atlas rewrites the textbooks, they want to be the ones holding the pen. And that's the heart of it. The fear of rewriting isn't about ego, it's about responsibility. Harvard scientists know that what they publish shapes how the world sees the universe. If they rush, they risk misleading generations. If they're cautious, they might capture the truth that lasts. So they watch Atlas with respect, with urgency, and with the quiet knowledge that this icy giant might just change the story of the cosmos we thought we knew. Space looks empty, but it's not. It's stitched together by gravity, by flows of motion, by hidden highways we can't see. Imagine rivers on Earth. Water follows channels. It carves paths downhill. Debris gathers in currents. Now stretch that to the stars. Objects ejected from planets don't just drift randomly. They follow arcs. They bend around gravity wells. They slip into streams shaped by the Milky Way itself. Cosmic rivers, flowing for millions of years. Our solar system sits at an intersection, a crossroads of invisible traffic lanes. Bits of rock, chunks of ice, ancient shards of alien worlds, all moving through like travelers on long journeys. Oumuamua followed one. Borisov rode another. And Atlas? It may be a visitor carried by one of the busiest routes. These highways are predictable. Not perfectly, but enough. Stars orbit the galaxy. Binary systems scatter material. Stellar nurseries eject debris by the ton. And over time, patterns form. Computer models reveal it. Curved trajectories, convergences, places where debris concentrates, like cosmic rest stops. These are the galactic highways. Think of it like city traffic. Big boulevards, side streets, shortcuts. The galaxy runs on similar flows. Only instead of cars, it's comets and asteroids. Some paths are crowded, others are empty. But the system is there, hidden in plain sight. Why does it matter? Because it tells us we're not isolated. Our solar system is not a lonely island. It's plugged into this network, constantly exchanging material, and that changes everything. Life's building blocks could ride these currents. Organic molecules, frozen in ice, hop from star to star. One system's leftovers become another's seeds. Harvard scientists think about this deeply. If Atlas is on such a highway, it's not just a comet. It's cargo, a message in a bottle, carrying the chemistry of its home system. Each visitor we study adds another piece to the map, a growing chart of interstellar roads. One day, we may even use them. Spacecraft hitching rides, letting gravity do the work. Riding currents between stars like ancient sailors caught the wind. It reframes the galaxy, not empty, not chaotic, but structured, connected, alive with motion. Galactic highways of debris, rivers of stone and ice, silent, ancient, unstoppable. And now, for the first time, we're beginning to read their routes. Every interstellar object that passes through is more than a curiosity. It's a signpost, a marker on the road. And Atlas? It might just be the biggest, brightest sign we've seen yet. Our solar system looks quiet. Planets orbit. Moons spin. Comets streak in and out. But to the galaxy, this place is more than just a home. It's a port of entry. Think of a harbour. Ships pass by. Some dock. Some just sail through. Some get stranded. That's our solar system, anchored on the edge of invisible highways of debris. We sit in a busy neighbourhood, not at the centre of the Milky Way, not in the outer dark, but right where traffic flows, close enough to other stars, close enough to routes where debris naturally travels. Gravity does the work. The sun's pull is massive. Its field stretches far beyond the planets, out into the Oort cloud, into interstellar space. Anything wandering close enough gets tugged inward. Some objects speed past. Oumuamua did. It slipped through, bent a little by the sun, then kept going. Others fall into longer visits, like Borisov, leaving trails as it warmed. And now Atlas, massive and active, pulled into view by the same trap. The planets help too, Jupiter especially. It's a gatekeeper. Its gravity redirects comets. Some it captures, some of it flings inward. Others it ejects entirely, hurling them back into the galactic sea. This constant juggling creates a cosmic customs station. Object approach. The solar system decides its fate. Some stay, some go, but all reveal themselves as they pass. That's why we keep seeing them here. It's not random chance. Its location, the sun's position, the planet's gravity, the galactic highways, together they make this a natural checkpoint. Astronomers compare it to a fishing net. Space is vast. Most debris slips by unnoticed. But the solar system is a knot in the web. Anything brushing close enough gets caught in its pull, and for a brief window, we get to study it. Harvard scientists pay close attention to this, because every object that enters carries information, alien chemistry, ancient history, material forged under foreign suns, samples from places we'll never reach ourselves. Each detection adds to a pattern. Each trajectory tells us about the highways outside. Each isotope and dust grain whispers of worlds unknown. The solar system becomes less a fortress, more a gateway, a hub where galactic travelers check in. So when Atlas appeared, it wasn't a surprise. Not really. It was expected, because this port of entry never closes. The only surprise was the scale, the brightness, the drama of its arrival. And the truth is simple. More will come, dozens, hundreds, thousands over time. Some small, some enormous, all carrying stories. Our solar system is a cosmic harbour, a checkpoint in the galaxy's vast network, and every ship that sails through leaves behind clues. Clues about where it came from and what else is out there waiting to arrive. We've seen 3: Oumuamua, Borisov, Atlas. But if 3 slipped through in just a handful of years, how many more are passing unseen? Astronomers wonder about this every night. For every one we detect, dozens could slip past. Dark, small, fast, hidden in the glare of the sun or the clutter of stars. Maybe they're icy shards from shattered worlds. Maybe they're rocky cores stripped of atmospheres. Some might be frozen oceans, drifting for millions of years. Others could be giant fragments of failed planets, torn apart by unstable suns. And then there's the stranger possibility. Visitors that aren't just natural debris. Structures are too regular, paths too precise, objects that raise more questions than they answer. Harvard scientists don't say this lightly, but they keep the door open, because space has surprised us before. Think about it. Our instruments can barely catch faint comets. We struggle to track objects only a few kilometers wide. So what about smaller ones? Or larger ones that never get close enough to reflect light? The galaxy is full of shadows, and in those shadows, who knows what's moving? Some visitors could carry alien chemistry we've never imagined. Exotic isotopes, molecules formed in the heat of other suns, even prebiotic compounds, seeds of life flung across the stars, delivered not by intent but by accident. Others might be catastrophic, rogue cores of gas giants, massive fragments that could disrupt entire planetary systems. Rare, yes, but possible, and the thought lingers. What if one heads our way one day? There's also timing to consider. Some visitors might arrive silently, pass through in weeks, leave no trace. We wouldn't even know they were here, like ships sailing past in fog. Others might linger. Their tails stretch for millions of miles. Their presence was etched into the night sky for months. The kind of object that changes human history. The kind people write myths about. So when we ask, what else might be out there? The honest answer is simple. Almost anything. From shards of alien mountains, to frozen oceans, to strange objects that don't fit our categories at all. And maybe that's why Harvard scientists fear Atlas. Not because it's dangerous, but because it's a reminder the universe is still full of unknowns. We've barely begun to see the traffic flowing past. Every discovery is a doorway. Every comet is a question. Every strange rock is a whisper from another world. What else is out there? The truth is both comforting and unsettling. We don't know. Not yet. But the sky is watching, and so are we. We used to think interstellar visitors were rare. 1 in a million. Maybe once in a human lifetime. But then came Oumuamua. Then Borisov. Then Atlas. 3 visitors. In just a few short years. That changes everything. If we've caught 3 with our still clumsy telescopes, how many more have we missed? Dozens? Hundreds? Maybe constant streams of debris are flowing past us right now, and we just don't see them. The unsettling thought is this. Maybe interstellar traffic is normal. Our solar system could be like a crossroads, a busy intersection in a galactic city. Shards of alien worlds, frozen oceans from dead stars, dust trails stretching across light years, passing through all the time. We might live in the middle of a cosmic highway, and only now, with modern sky surveys, are we realizing it. Think about the consequences. If it's common, then every few years we should expect new arrivals. Each one carries chemical fingerprints from distant stars. Each one whispering stories of alien chemistry. Each one rewriting what we thought we knew. But here's the twist. Constant traffic doesn't just mean discovery. It means missed chances. For every comet like Borisov we catch, dozens may glide past unseen, carrying secrets we'll never touch, lost forever in the dark. The traffic theory also changes how we think about life itself. If material is constantly being exchanged between stars, then maybe the seeds of life ride these objects. Microbes frozen in ice. Organic molecules are protected in rock, drifting across light years, delivered to new worlds by cosmic accidents. Maybe life spreads this way like spores on the wind. It also means danger is not impossible, not from Atlas, not today, but from the simple fact of numbers. If thousands of objects are passing, eventually one might get too close, too big, too fast. That's why Harvard pays attention. Not panic, just preparation. Constant traffic also forces us to rethink history. What if ancient people saw more of these? Bright comets blazing across the sky for months, fragments breaking apart in spectacular displays. Were myths and legends seeded by visitors we never recorded? The more we look, the stranger it feels. Not empty space, not rare encounters, but a flowing river of cosmic wanderers, always moving, always passing, always watching. So what if they're common? It means the universe is more alive than we thought. It means our solar system isn't isolated. It's a port, a place on the map, and traffic never stops. That's not just unsettling, it's profound, because every object is a messenger, and messengers keep coming. Here's a thought that refuses to stay quiet. What if these interstellar visitors aren't just frozen rocks? What if they're couriers, messengers carrying the raw materials of life itself? Scientists call it panspermia, the idea that life, or at least its building blocks, can travel across the galaxy, hidden inside comets, locked in ice, protected by stone, and when those objects land on a planet with the right conditions, they sow the seeds of biology. Think of it like spores drifting through space. A flower releases pollen on the wind. Some grains vanish into nothing, but some find soil. Some take root. Some bloom into new life. Now replace the flower with a star system, and the pollen with icy comets and rocky fragments. Suddenly, life isn't just a local accident. It's a galactic story. Here's where it gets eerie. Atlas isn't ordinary. It carries alien ice, alien isotopes, alien chemistry. Its molecules were forged around another star under conditions we can only imagine. What if, frozen within, are amino acids, the very letters of life's alphabet? What if the ingredients that once sparked life on Earth came from visitors like this? Meteorites that have landed here already contain amino acids. We've found them, proof that chemistry in space can brew the recipes of biology. If local comets and asteroids carry them, why not interstellar giants? Imagine Earth 4 billion years ago. Young, barren, oceans are just forming, and then cosmic deliveries arrive. Icy messengers crash into the seas. They melt, they spill their chemistry, and slowly, molecules assemble into the first stirrings of life. If panspermia is real, then we're not just children of Earth, we're children of the cosmos. Every living thing here might trace its roots to ancient wanderers from other suns, and it cuts both ways. If visitors can bring life, they can also carry it away. A chunk of Earth blasted into space by an asteroid strike could sail for millions of years. It could land on another planet, and there, in some distant ocean, Earth's microbes could awaken. Life traveling, life spreading, life refuses to stay confined. That's why these interstellar objects matter. They aren't just rocks, they are possibilities. They're bridges between worlds. Each one could be a seed waiting for the right soil. The thought is both humbling and electrifying. We may not be alone. We may never have been alone, because life's ingredients may be everywhere, carried on the backs of cosmic wanderers like Atlas. And maybe, just maybe, that's why Harvard scientists pay attention. Not out of fear of impact, but out of awe for what these objects might carry. If you don't want to miss more of these cosmic whispers, subscribe now, because the story of life might be written not just here, but across the stars. When we imagine interstellar visitors, we often think of gifts, seeds of life, a cosmic hand reaching across the void. But what if some of those gifts aren't so friendly? Space isn't gentle. Radiation blasts every object that drifts unshielded. Cosmic rays carve chemistry into strange shapes. Some molecules that form under those conditions are completely alien to us. They don't play by Earth's biological rules. If one of these substances touched our environment, would it mix harmlessly? Or would it disrupt delicate chains of life we've built over billions of years? And then there's the chilling idea of viruses. Tiny, parasitic fragments of life. Here on Earth, viruses rewrite the software of living cells. What if icy wanderers carried similar fragments? Maybe not viruses as we know them. Those are tied to Earth's biology. But what about virus-like structures? Molecular machines that evolved in another system. They might not infect us. They might not even recognize us. But their chemistry could still be unpredictable, still dangerous. Scientists admit we don't know. We've already found meteorites here containing amino acids and other organics. But suppose one day we find something more complex, something not inert, something active. Suddenly, Panspermia has a darker twin panpathogenia, the spread of threats across the stars. Even if no alien biology lurks inside, radiation itself is a hazard. When an interstellar comet approaches the Sun, it sheds clouds of gas and dust. Those particles can be charged, reactive, or unstable. What if Earth ever passed through a dense tail? The fallout could change atmospheric chemistry, alter weather, or, at extreme scales, trigger biological stress across ecosystems. And don't forget size. Atlas isn't a pebble, it's a giant. If a fragment of it were ever on course with Earth, even a small chunk could spell disaster. Impact winters, mass extinctions. We've seen it before in our history. The dinosaurs didn't survive their visitor from the sky. This is the subtle edge of Harvard's concern. It's not just the mystery of what's inside. It's the knowledge that we don't know what rules these objects follow. Their chemistry is alien. Their history is alien, and so their risks might also be alien. Most of the time, they pass quietly. They light up, then fade away. But each one is a question mark. Each one is a reminder that not all visitors bring comfort. Some bring uncertainty, and in that uncertainty lies the shadow of threat. That's why we watch them, why we measure, analyze, and sometimes worry, because out there, among the highways of stars, not every package delivered to our doorstep is guaranteed to be safe. For most of human history, the night sky was a mystery. We looked up, saw stars, maybe a comet now and then, but most of what passed through went unseen. That's changing. Now we have eyes everywhere, cameras that never sleep, machines that watch the heavens with tireless patience. Surveys like Catalina, Linear, Atlas itself, they scan the entire visible sky night after night, not just peeking at one star or one planet, but photographing everything. Think of them like cosmic security cameras. They take snapshots, compare them to last night, then to the night before. If something moves, they know. If something changes brightness, they know. Algorithms do the heavy lifting. Millions of points of light checked in minutes. The computer finds the stranger in the crowd. 20 years ago, this would have been impossible. Processing power wasn't there. Detectors weren't sensitive enough. Cameras couldn't see faint objects in the dark. But technology leapt forward. Suddenly, we can spot things thousands of times fainter than film ever caught. And here's the key. It's not just one observatory doing this. It's a network, a global grid of telescopes. When one sees something, others check it. Confirmation, tracking, details. This teamwork multiplies power. An object that might slip away from one camera gets caught by another. No single sight can see everything, but together they close the gaps. That's how we've caught interstellar visitors at all. Without the survey revolution, Oumuamua would have passed in silence. Borisov would have been just another invisible shadow. Atlas, the giant, would still be out there, unknown. And yet, even with this progress, there are limits. The sun blinds half the sky. Crowded star fields hide faint motion. Some visitors race too fast for even our best systems. But still, we see more now than we ever did. The revolution means we're no longer blind. The cosmos is alive with motion, and for the first time, we can track it. Each detection feels like opening a curtain, a glimpse of the unseen traffic lanes above, a new piece of the puzzle. Every night, data streams in, petabytes of stars, streaks, shifting dots. Hidden in those numbers are the stories of alien worlds, chemical samples, cosmic time capsules, warnings, and the cameras keep watching. Quiet, steady, patient. The sky is no longer just for dreamers. It's for machines that never blink, machines that remind us we're not alone in this traffic. And every so often, one of those lights brings us face to face with the unknown. Once, astronomers had to hunt by hand, staring at glass plates, comparing dots of light. Night after night, exhausting, slow, easy to miss something. Now, the machines do it for us. Cameras take millions of images. Algorithms process them at lightning speed. They don't blink. They don't tire. They don't lose focus at 3 a.m. Think of them as cosmic night guards, watching the heavens. Every star, every faint flicker, checking for motion, checking for change, looking for something that doesn't belong. Here's the brilliance. Algorithms compare tonight's sky with last night's and the one before that. If a point of light shifts, even by a hair, the system flags it. It could be an asteroid. It could be a comet. Could be an interstellar intruder. The volume is staggering. Billions of data points. Tens of thousands of moving objects every year. The computer handles it. No human team could keep up. And it's not just speed. It's pattern recognition. These algorithms are trained to spot weirdness. Odd orbits. Strange brightness changes. Hyperbolic paths. The kind that scream, "Not from around here." That's how Oumuamua was noticed. That's how Borisov was tracked. That's how Atlas became headline news. All because the machines caught a tiny flicker of motion against a sea of stars. Imagine standing in a stadium filled with people, all frozen. One person shifts an inch. The computer sees it instantly. That's what they do with the sky. But the machines aren't perfect. False alarms happen. Birds, planes, camera noise, even cosmic rays hit detectors. So, humans still double check. But the first line of defense belongs to code. And every year, the code gets better, smarter, more sensitive, able to pick out fainter signals and smaller movements. Objects, once invisible now, glow under digital scrutiny. This is why Harvard and other institutions care so much. The fear isn't that the sky hides nothing. It's that it hides too much. That countless objects slip through. Only algorithms can keep pace. Think of it this way. Our galaxy is busy. Debris, comets, asteroids, thousands moving at any moment. Humans alone can't manage that traffic. But computers can. And when something from another star drifts in, they're the only reason we even notice. The irony? For all their brilliance, they're still just catching scraps. 3 interstellar visitors so far. But the math says millions more must pass unseen. Even our sleepless guardians miss most of them. Still, without them, we'd be blind. Without them, Atlas would just be another ghost in the dark, and we'd never know the universe was knocking at our door. We've built sky surveys. We've trained algorithms. We've pointed the best telescopes we have at the heavens. And yet, it's still not enough. The truth is brutal. Space is just too big. Even with cameras scanning non-stop, we're only scratching the surface. Our eyes cover the sky in slices, never the whole dome at once. Millions of stars, billions of objects, too much to watch all at once. Here's the kicker. Interstellar visitors don't wait for us. They fly in unannounced. They race across the sky at insane speeds. And by the time we notice them, they're already leaving. Oumuamua, we saw it on its way out. Borisov, caught only because it burned bright. Atlas, barely in time to point our instruments. It feels like chasing ghosts, always a step too late. Always wishing we had just a few more weeks. But the universe doesn't give extensions. Even computers, fast as they are, have limits. They can't watch every star in every galaxy. They can't process infinity. And telescopes, no matter how powerful, can only stare where we aim them. Every direction we choose leaves 10,000 others unwatched. That's the heart of the problem. We lag because space doesn't sit still. Stars move, comets move, visitors sweep past in arcs we can't predict. By the time we find one, its story is already half told. Think of it like trying to watch raindrops in a storm. You can track a few, you can measure their paths, but most just flash past unnoticed. And somewhere in that rain, one drop might carry something extraordinary. but unless you catch it, it's gone. This is why Harvard scientists worry. Not about collision, but about ignorance, about how much we'll never see. Every missed visitor is a lost library. A piece of another world was erased from our reach forever. We can add more telescopes, launch more surveys, refine algorithms until they hum with intelligence. But the imbalance remains. The sky is endless, our gaze is narrow, and the visitors will always outnumber our chances. This lag shapes the field of interstellar archaeology. It forces humility. It reminds us that our picture of the cosmos is incomplete. That's what we know is just the tiniest fraction of what passes us by. And maybe that's the real fear, that while we celebrate the few we've caught, Oumuamua, Borisov, Atlas, dozens more have already slipped past in silence. Unknown, unseen, unmeasured, the machines never sleep, the surveys never stop, and still we lag behind. That gap between what's out there and what we can see is where the mystery lives. It's where the fear comes from. And it's why the story of interstellar visitors is only just beginning. Imagine this: a spacecraft not sent toward a target, but waiting, silent, patient, like a trap. That's the Comet Interceptor mission, a bold idea from the European Space Agency. Instead of chasing a comet already spotted, this probe will wait in space, stationed at a stable point L2, about 1 million miles from Earth. From there, it can spring into action the moment something unexpected appears. Why does this matter? Because of Oumuamua, because of Borisov, because of Atlas. We've seen how fast these interstellar visitors come and go. By the time we notice them, it's too late to launch. Our rockets can't catch up. But if we already have a spacecraft waiting, the story changes. Comet Interceptor will launch with no target. That's unusual. Space missions usually have a destination planned years in advance. Not this one. It's like a cosmic ambush. The probe waits. We watch the skies. When something interesting appears, it pounces, and it won't be one spacecraft. It will be split into 3, a mothership and 2 smaller probes. Each will approach the target from a different angle. 3 perspectives, 3 streams of data. A 3D picture of something we've never seen up close before. If it gets lucky, it may be the first human-made machine to intercept an interstellar visitor. Not just watch from Earth. Don't just take blurry photos from afar, but fly beside it. Smell its gases. Touch its dust. See what it's made of. Think about what that means. We've speculated about alien chemistry, about isotopes locked in ice, about strange molecules born around foreign suns. Comet Interceptor could test those ideas directly. It could show us if Atlas-like visitors carry building blocks of life, or if they're carrying something more dangerous. The mission is a hedge against the unknown. We don't know when the next visitor will come. We don't know where, but we know it will, and when it does, Comet Interceptor will be waiting. It's also a statement of intent. Humanity is done just watching. We're ready to meet the travelers halfway. No more missing our chance. No more regrets like Oumuamua. Harvard scientists follow this closely, because it's the first time we're moving from passive astronomy to active interception. It's the start of interstellar fieldwork, the next step in interstellar archaeology. The spacecraft hasn't even launched yet, and already it feels like history. A hunter in the dark, a net cast into cosmic traffic, a chance to turn speculation into fact. One day, when that visitor finally crosses paths with Comet Interceptor, we may learn truths that change how we see the galaxy. And this time, we won't just watch it slip away. We'll be there, waiting. Picture the ocean, endless waves, ships moving across the horizon. Some known, some unexpected. Now, replace that ocean with space. Replace ships with comets and interstellar visitors. That's what astronomers are trying to patrol. A coast guard of the cosmos. The Comet Interceptor is part of it. So are the sky surveys. So are the computers scanning the heavens every night. Together, they form a watchtower system, always looking outward, always ready for a stranger. The comparison to a coast guard fits, because most of the time, it's quiet, just monitoring, nothing dramatic. But the job isn't about the calm, it's about the surprises, the unexpected intruder cutting across the waves, something you didn't see coming. That's how Oumuamua felt, that's how Borisov felt, and that's why Atlas alarms people. Each arrival is a reminder we don't own this ocean. We just live on the shore, so the Coast Guard of the cosmos doesn't rest. Telescopes keep scanning, algorithms keep learning. Satellites and missions like Comet Interceptor stay on standby. The whole system is built on readiness. Because the next visitor won't send an invitation, it'll just appear. Harvard scientists know this. It's not about panic. It's about preparation, being ready to chase, study, and understand. Because every object is a message in a bottle, a relic from another star. It could carry secrets about alien chemistry, or warnings about how planetary systems break apart, or even fragments of building blocks that once sparked life. Think of it as cosmic border security, not to keep things out, but to make sure nothing passes unnoticed. Because every missed object is a lost chance, and chances in this field don't come often. The Coast Guard metaphor also shows the limits. Even the best patrol can't watch every wave. The ocean is too big. The same is true for the galaxy. There will always be blind spots. There will always be something slipping past. But that's why the system is growing. More telescopes, more missions, more eyes on the sky. The future could even bring swarms of tiny spacecraft, cheap, fast, and ready to intercept. Like lifeboats racing toward a flare, that's the long-term dream. A true interstellar coast guard. For now, the effort is just beginning, but it's a shift in mindset. We're no longer passive observers of the sky. We're active guardians, not against danger necessarily, but against ignorance. Because what Harvard fears most isn't destruction. It's missing knowledge, missing the chance to learn, missing the chance to understand our place in the cosmic ocean. The Coast Guard of the cosmos won't stop every intruder, but it will make sure more of them are seen, tracked, studied, turned into knowledge instead of a mystery. And in that watchful silence, humanity is taking its first steps toward becoming a galactic sailor, not just a shore-bound spectator. Space doesn't wait. Interstellar visitors don't linger. They rush in, they rush out, and by the time we notice them, the clock is already ticking. That's the cruel truth. Oumuamua was already leaving when it was found. Borisov gave us months, not years. Atlas is bigger, brighter, but still fleeting. Every day, it drifts farther. Every hour, it fades. Studying them is a race against cosmic time. And that's why fast response technology isn't optional. It's survival for knowledge. It's the difference between catching a glimpse and gathering a library of data. Our current system isn't built for speed. Space missions take decades to design, test, and launch. By the time a spacecraft is ready, the visitor is long gone. It's like building a lifeboat after the ship has already sunk. So scientists are rethinking everything. Instead of waiting, they're preparing. Spacecraft like the Comet Interceptor won't chase. They'll wait, on standby, like a fire truck parked at the station, ready to launch at a moment's notice. But even that isn't enough. The window of opportunity is too short. Interstellar objects can be visible for weeks, sometimes only days. We need technology that reacts as fast as the discovery itself. That means automation. Algorithms that not only find the intruder, but also instantly alert mission control. Pre-programmed spacecraft that can receive a trajectory update and adjust course without years of planning. It's space science turned into an emergency response. Imagine it. A visitor is spotted tonight. Within hours, telescopes worldwide confirm the orbit. Within days, a spacecraft already stationed in space pivots and burns its engines. Weeks later, it intercepts. That's the dream. And Harvard scientists know the urgency, because every missed chance is painful. Its data will never get back. It's a chemical fingerprint erased by sunlight. It's cosmic history slipping through our fingers. Racing against time also means building smarter instruments, ones that can collect more data faster with less power, spectrometers that can decode alien chemistry in minutes, high-resolution images that can capture surface detail in seconds, the kind of tech that doesn't blink when the universe throws something unexpected our way. There's fear in the urgency, fear of being too slow, fear of missing the story written in alien atoms, fear that by the time we're ready, the universe will have already moved on. But urgency also brings focus. It forces science to shed its comfortable pace, to move faster, to prepare better, to treat interstellar visitors not as rare anomalies, but as expected arrivals, because they will keep coming, and will keep racing. And someday soon, the race won't just be about watching, it'll be about catching, touching, maybe even bringing a piece of another star system home. That's the finish line, and the clock is already running. Fear gets a bad reputation. We think of it as weakness, hesitation, or paralysis. But in science, fear is often something else. It's curiosity wearing a darker mask. When Harvard scientists talk about fearing objects like 3I, Atlas, they don't mean panic. They mean reverence, respect for the unknown, the kind of awe that comes from standing at the edge of a cliff and staring into the fog below. Oumuamua gave us that feeling. It didn't behave like a comet. It didn't shine like an asteroid. It broke the rules, and in doing so, it whispered, "The universe has more surprises than your textbooks can handle." That whisper sparked fear, not fear of collision, but fear of ignorance. Fear of realizing that the universe is stranger than we imagined. Borisov soothed that fear slightly. It looked like the comets we know. It followed the rules. But even then, it carried alien chemistry, molecules born around another Sunday. And with it came another truth. The universe isn't empty. It's a busy crossroads of material. That's exciting, but it's also unsettling. Now, Atlas takes the stage, and it magnifies the unease. It's bigger, more active, more chaotic, and it's here for only a fleeting moment, a roaring giant that gives us a rare chance to study alien ice directly. But also a reminder, we've probably missed thousands just like it. That's where the fear comes in. It's the fear of opportunity slipping away, the fear of missing knowledge, the fear of admitting we still don't know what we don't know. But if you look closer, that fear is just curiosity with urgency. The unknown is magnetic. It pulls us forward. It makes scientists point bigger telescopes at the sky. It inspires missions like the Comet Interceptor. It drives late-night debates at Harvard about whether we're seeing natural debris or something more. Fear sharpens the senses. It asks the uncomfortable questions. What if interstellar visitors carry life's building blocks? What if they carry alien threats? What if they show us that our solar system is ordinary, or worse, irrelevant in the grand design of the galaxy? These aren't easy thoughts, but they are necessary ones, because fear forces humility. It reminds us that we are small, that our knowledge is fragile, that the universe doesn't owe us answers. And yet, fear also fuels courage. We look anyway. We chase shadows across the sky. We build machines to intercept travelers we may never see again. We face the unknown not to banish fear, but to transform it into understanding. So when scientists say they fear 3I, Atlas, don't picture panic. Picture wide eyes in the dark. Picture questions that burn hotter than answers. Picture curiosity so fierce that it cloaks itself as fear. Because fear, in science, isn't the end. It's the beginning of discovery. Fear isn't always a warning. Sometimes it's a spark, a push, a nudge toward the unknown. When scientists at Harvard look at 3I, Atlas, they feel a kind of fear that doesn't paralyze. It motivates. It forces questions that have no easy answers. Why is it so active? Why is it so massive? Why did it arrive here, now, in our skies? Every uncertainty carries a challenge. Every anomaly carries a potential discovery. That unease drives observation campaigns, telescope time, and international coordination. It fuels nights spent poring over data, measuring every particle escaping its nucleus, every change in its trajectory, every subtle color in its tail. Think of interstellar objects as messengers. They arrive silently, crossing billions of miles, carrying the history of their birth systems. But they don't announce themselves politely. They challenge assumptions. They show us that our models, however precise, are incomplete. Fear becomes a guide. It points to what we don't yet understand. Oumuamua was the first, a strange, elongated object, accelerating unexpectedly, refusing to fit our expectations. It worried scientists, but it also inspired them. Borisov came next, predictable, textbook perfect, easing some of that worry but still carrying chemical secrets. Atlas dwarfs them both. It's massive, active, visible, and fleeting. The fear surrounding Atlas is twofold. One part is the practical. We have a limited window to study it. It moves fast. Solar glare will soon hide it. Miss it, and a million-year-old lesson from a distant star system is gone. The second part is philosophical. What if it doesn't behave as expected? What if its chemistry or structure challenges our most fundamental understanding of planetary systems? This duality, immediate urgency, plus existential uncertainty, drives science forward. It forces innovation. Telescopes and surveys are upgraded. Algorithms are refined. Global networks coordinate. Missions like the Comet Interceptor are planned with split-second timing in mind. Fear transforms into disciplined action. It converts awe into experiments, questions into data points, mystery into measurable parameters. Without it, discovery slows. Without unease, we would not pursue the faintest trace of alien molecules, the tiniest shift in orbital mechanics, the subtlest hints of chemistry formed around another star. Fear is also a teacher. It reminds us of our limits. We're capable observers, but the universe is vast. Interstellar objects arrive unannounced, travel faster than we anticipate, and carry histories billions of years long. We learn humility. We learn precision. We learn to chase knowledge relentlessly. Every breakthrough begins with unease. Every great discovery contains a seed of fear. The fear that we might be wrong. The fear that we might miss something vital. The fear that the universe is stranger than we imagined. And from that fear, motivation grows. It turns uncertainty into action. It turns fleeting observations into global campaigns. It turns cosmic mysteries into lessons for humanity. So, when Harvard scientists fear 3I, Atlas, it's not panic. It's an inspiration. It's the engine behind telescope time, computational analysis, and next-generation spacecraft. It's the reminder that the unknown isn't a threat, it's a challenge. A call to explore, measure, and understand. Fear, in science, is not weakness. It is the pulse that drives curiosity, discovery, and the relentless pursuit of knowledge. Fear has a strange duality. It alarms us, but it also teaches us. When scientists observe 3I, Atlas, they feel a quiet fear, not of impact, not of disaster, but of perspective. It's a fear rooted in scale, the kind that reminds us how small, fragile, and temporary we are in the cosmic arena. Atlas is enormous. Its journey spans millions of years, billions of miles. It has survived the harshest conditions in the galaxy, cosmic radiation near absolute zero temperatures, micrometeorite bombardment, it carries within it chemical histories older than our planet. Its passage through our solar system is brief, a mere blink in its life story. In comparison, human existence is minuscule. We are observers on a tiny rock, circling an ordinary star in one unremarkable corner of a vast galaxy. This perspective is humbling. We often imagine the universe as something we can control, measure, and predict. But Atlas challenges that illusion. It arrives unannounced, traverses interstellar highways invisible to our surveys, and obeys rules far older and larger than anything we've engineered. Our telescopes, powerful as they are, can only capture fragments of its journey. Our calculations, precise though they may be, trace only a fraction of its past. The cosmos operates on scales and times that dwarf us. Fear, in this context, is awareness. It reminds us of limits our instruments, our observation windows, our lifetimes. We cannot follow every interstellar visitor, cannot catalogue every fragment, cannot foresee every cosmic event. For every atlas we detect, countless others have passed silently, leaving no trace for our telescopes to catch. We are, in essence, visitors ourselves on a cosmic stage where the main actors have existed for eons. But humility, born of fear, is not defeat, it is clarity. It sharpens the scientific mind. It encourages collaboration, careful measurement, and patience. It transforms the unknown from a source of anxiety into a source of insight. We study Atlas not to dominate it, but to understand it. Every molecule, every dust grain, every particle of ice tells a story far older than humanity. And in listening, we gain perspective. The humbling effect extends beyond data. Atlas's path through our solar system is fleeting. We cannot interact with it at will. Its appearance is accidental, random in timing, yet meticulously recorded in its motion by the laws of physics. We are spectators in a theatre we didn't build, watching an event we cannot control. In recognizing this, scientists feel awe mixed with fear and a profound sense of place. Fear as humility also reshapes our philosophical view. It reminds us that our solar system is not isolated. We are part of a galactic ecosystem. Material, energy, and even life's building blocks flow between stars, indifferent to our existence. Atlas, with its alien chemistry and interstellar origin, exemplifies this connectivity. It carries not just matter, but perspective, that life, history, and matter exist far beyond the pale of Earth. This cosmic humility has practical consequences. It motivates rapid response in science, fosters international collaboration, and inspires technological innovation. It encourages careful study of objects before they vanish from view, recognizing that we may never get another chance. It transforms fear into wisdom. Fear reminds us that we are small, but also that our curiosity and effort can illuminate even the tiniest corner of the universe. In the end, observing Atlas reminds us of a simple truth. Humanity is minor in scale, brief in time, yet capable of profound understanding. Fear humbles. Fear inspires. Fear teaches that to explore the cosmos is not to conquer it, but to recognize our place within it. And in that recognition, both science and soul expand. Every interstellar visitor tells a story. They arrive unannounced. They carry secrets from worlds we will never see. Oumuamua whispered. Borisov spoke clearly. Atlas shouts. Each molecule is a message. Water, dust, organic compounds, all frozen time capsules. They reveal chemistry from alien suns, not filtered, not altered, not biased, pure. These objects travelled for millions of years, across vast, empty space, through radiation, collisions, and cosmic cold. Yet they survive. They arrive intact. The size of the visitor matters. Small ones teach subtle lessons. Medium ones confirm theories. Giants like Atlas overwhelm us with data. Every detail is precious. The tale is a library. Gas and dust streams carry history. Blue regions mark ionized gases. Yellow and red reflect dust. Each particle tells us about the birthplace. Speed encodes origin. Trajectory reveals the journey. Velocity acts like a cosmic fingerprint. Even minor deviations hold clues. Astronomers decode these signals like detectives. Every passing moment counts. Observation windows are short, weeks, maybe months, before they vanish. Telescopes worldwide join the relay. Hubble captures the finest detail. Ground-based instruments fill in gaps. Spectroscopy reads alien DNA. Isotopes mark temperature and pressure. Organic compounds hint at planetary chemistry. Some molecules only form over geological time. Each chemical signature is a message from afar. We learn about star systems, not just comets. These visitors are educators. They reveal processes invisible from light years away. They validate theories, challenge assumptions, rewrite possibilities. Detection is no longer passive. Surveys and algorithms scan the sky constantly. Automated telescopes act as cosmic sentinels. They spot intruders we couldn't see before. Yet, we still miss most. Hidden objects slip past in shadows. Speed and trajectory hide them. Many visitors go unnoticed. Every detection is a gift. Each messenger carries a choice. Study it, and knowledge grows. Ignore it, and opportunity vanishes. They deliver lessons in chemistry, physics, and cosmic history. We are recipients, not owners. The universe sends these messages freely. Humans must read carefully. Every photon, every molecule, every data point matters. Oumuamua, Borisov, Atlas. They are the first of many. Each arrival enriches our understanding. Each tail, each jet, each particle tells a story. These objects are messengers from alien worlds. They travel for millions of years to meet us briefly. We catch their signals. We study their composition. We marvel. Every visitor is a gift. Alien knowledge delivered in ice and dust. A fleeting opportunity to touch the cosmos, to learn beyond Earth, to expand our understanding. They remind us the galaxy is alive. It sends teachers disguised as comets. We only need to listen. Every interstellar visitor carries secrets. Some are obvious. Others are subtle. Oumuamua, silent and elongated, baffled astronomers. Borisov behaved predictably. Atlas challenges every assumption we have. Even with modern telescopes, data is incomplete. Every observation shows part of the story. Some regions remain hidden. Some molecules remain undetectable. Some phenomena occur too fast or too faint to measure. These objects are riddles wrapped in cosmic ice. They come from places we cannot reach. They formed around stars billions of miles away. They traveled millions of years. Every detail holds clues about alien chemistry, physics, and history. Trajectory tells a tale. Velocity encodes a birth story. Rotation reveals internal structure. Outgassing patterns hint at surface composition, yet we see only snapshots in time. Their journeys are unique. No two visitors follow the same path. Some originate from chaotic star systems, some from stable, ancient neighborhoods. Every encounter is a case study in cosmic survival. Even the largest telescopes reveal limits. Shadows hide features. Radiation masks molecules. Distance blurs detail. Each measurement is a best guess, a partial answer. Yet, we persist. Scientists decode patterns. They analyze tails, jets, and isotopes. They simulate millions of years of motion. Every clue brings understanding closer, but never complete. Mystery drives discovery. Questions outweigh answers. What processes formed these visitors? How did they survive interstellar space intact? What secrets lie in their cores? Every messenger reminds us of our limits. The universe does not yield its knowledge easily. It offers glimpses, hints, and fragments. We interpret, theorize, and predict. But certainty is rare. Some answers may never come. We may never see the full surface. We may never sample the interior. We may never know all the chemical reactions that occurred in alien nurseries. Yet the pursuit itself is valuable. The mystery inspires awe. It reminds us that the cosmos is vast, complex, and unpredictable. Each visitor is a riddle written in ice, dust, and gas. Every detail carries lessons for those patient enough to observe. In this uncertainty lies excitement. Every discovery opens new questions. Every measured molecule, every observed tale, is a clue in a cosmic puzzle. And while we may never solve it fully, the journey of investigation defines science. Every messenger is a mystery. They arrive, teach, and vanish. They leave questions we may never answer. And in that unknown, we find wonder. We study, we learn, we marvel, and we keep looking. 3. Atlas doesn't shout. It whispers in patterns only careful observation can detect. Harvard scientists don't fear an impact. They fear what they don't yet understand. Its size is enormous. Its activity is off the charts. It behaves unlike any comet studied before. Every molecule escaping its nucleus carries information. Some of it is familiar. Some of it is completely alien. The chemical signatures are unusual. Water isotopes differ from anything in our solar system. Organic molecules hint at chemical processes from another star system. Radiation-altered compounds tell a story of millions of years in interstellar space. Yet, interpreting these signals is challenging. Trajectory offers clues. Speed encodes origin. Rotation and outgassing reveal internal structure. But even with advanced models, uncertainty remains. Small errors in measurement compound over millions of miles. A single unknown variable can rewrite the story. Harvard researchers fear that 3I, Atlas, might be an outlier. It doesn't fit existing comet models. It may have formed under conditions unlike anything we know. Its chemistry could challenge long-held assumptions about planetary formation and stellar evolution. Detection is limited. Observation windows are brief. Solar glare, night-only visibility, and narrow telescope fields constrain what we can see. We may be missing critical behavior. An entire layer of data might be invisible until it's too late. The warning is subtle. This visitor reminds scientists how much remains unknown. It's a call to improve detection, modeling, and rapid response. Each passing day carries potential insights that vanish as the comet speeds away. 3I. Atlas is a messenger. It brings matter from a distant star system. It brings chemistry frozen for millions of years. It brings data about environments no human has ever visited. But it also reminds us of our limits. Harvard scientists are cautious. They know that even the most careful observation cannot fully capture the visitor's secrets. They understand the risk of missing knowledge. They recognize that unseen variables could change interpretations. The fear is silent. It is not panic or alarm. It is the sober awareness of uncertainty. It is the understanding that the universe is larger, stranger, and more complex than our models allow. 3I. Atlas is both an opportunity and a warning. It shows us what we can learn. It reminds us of what we can't. And that tension, that gap between knowledge and mystery, is what keeps scientists vigilant. Harvard watches carefully. They track, measure, and simulate. They prepare for questions we may not yet know to ask. And in the quiet of observation lies the true weight of fear, the fear of the unknown. Hello there, friend. Take a deep breath. The night sky stretches above you, vast and endless. Amid its darkness, mysteries like 3I, Atlas, drift silently. No need to panic. These cosmic wanderers are distant, far beyond the reach of our daily lives. The universe is enormous. Its scale dwarfs everything we know. Yet, here we are, on our small blue planet, watching and learning. Each observation, Each photon captured by telescopes brings a little more understanding. We are explorers, quietly charting the invisible highways between stars. Think of 3I, Atlas, as a messenger, not a threat. Its journey spans millions of years, across light years of space. Its story is written in atoms, molecules, and chemical fingerprints. We may never fully solve its mysteries, and that's okay. Curiosity, not fear, drives us forward. Even in the unknown, there is beauty and wonder. Sleep beneath the stars, knowing that scientists are watching. They measure, track, and study. They prepare for what comes next. Our curiosity protects us, guiding understanding with care and precision. The universe is vast, but so is our capacity to observe and learn. Close your eyes and imagine the comet gliding through the void. Its tail stretches across millions of miles, glowing softly in reflected sunlight. Particles released thousands of years ago now drift past planets in our solar system. Every molecule tells a story. Every trajectory is a testament to cosmic order. It is a quiet reminder of our connection to the galaxy around us. Sleep, knowing that knowledge is growing. Every telescope, every computer algorithm, every dedicated astronomer adds to the story. We learn about distant stars, alien chemistry, and the history of the cosmos. The unknown is not to fear, it is an invitation. And as you drift into dreams, remember this: the universe moves slowly, patiently, while we watch with wonder. Our solar system is a small port of entry in a vast galactic ocean. Visitors will come and go. Some will leave messages in molecules, others in trails of light. We are here to read them. So, rest easy. The night is quiet. Stars shimmer softly above. And somewhere out there, 3I, Atlas continues its journey, distant yet full of stories. We are safe, we are learning, and one day, these cosmic visitors will teach us more than we ever imagined. If you want to stay on this journey, uncover mysteries, and watch the universe reveal itself, subscribe now. Join us as we explore, learn, and dream beneath the stars. Good night, sleep well. The cosmos will be here tomorrow, still whispering its secrets.